Hello students, today I'm here with the same topic, predicate and quantifiers. So I have taken apart in the previous section predicates and quantifiers we have discussed, and about the introduction of predicates and quantifiers I have discussed. Now here we are moving on to the same topic with some more extra problems, predicates and quantifiers. So in this topic, first of all, let me take some problems I have given here. I have taken some examples and I have explained here. So first question is, find the negation of the quantified expression. Every student in your class has taken a course in calculus. So we have to write the negation of the statement. So in this statement here we can see that every student, so it is mentioned here every student, so that is every denotes the quantifier. So first of all, you have to see negation of the quantified expression. First of all, you have to verify that here ആദ്യം നമ്മളിവിടെ ചെക്ക് ചെയ്യേണ്ടത് ഇതിൽ ഏത് ക്വാണ്ടിഫയർ ആണ് അപ്ലൈ ചെയ്തിരിക്കുന്നത് എന്നുള്ളതാണ്. So first of all, you think about which quantifier has applied. So here for every is given here, which means that for every is a quantifier. So for every, we know that for every, for all, these are all universal quantifiers. For all means these are all universal quantifiers. So in this statement അത് നമുക്ക് ഐഡൻറ്റിഫൈ ചെയ്യാൻ പറ്റുന്നുണ്ട്. അടുത്തത്, ഈ സ്റ്റുഡൻറ്റ് ഇൻ യുവർ ക്ലാസ്, എവറി സ്റ്റുഡൻറ്റ് ഇൻ യുവർ ക്ലാസ് ഹാസ് ടേക്കൺ എ കോഴ്സ് ഇൻ കാൽക്കുലസ്. So this statement is an universal quantification, which means that it denotes as, let us take the statement to be P of x. So let us first define the predicates. So before define the predicate, we have to mention the variables. So what is that domain we have to take? So how many variables we can assume? That's the thing first you have to think about. So first of all, when you consider here, let us take first, let x denote the domain of the student in the class. Let me take first, let x denote the student in the class. I'm taking like this first, then I'm defining the variable that to be the statement to be P of x. So let me take first P of x. In this P of x statement, which means that if x is the student in the class, then I can say, so if this is x, then I can say that x has taken a course in calculus, which means that the quantification of this statement is for all x P of x. Now what is the negation of this quantification? So negation of negation of this quantification is, we know that what is the negation. So first of all, the negation is denoted by the symbol as there exist, isn't it? So for all means negation for all, you can write like this, negation for all x P of x. Now in this statement, this is negation for all is equivalent to there exists x negation P of x. So this is the equivalence condition, you remember that. So I'll come into this one, this reason why this is given. So this is a law based on this topic. In this continuation, after this I'll explain about this. So for all x P of x means the negation is negation for all x P of x, which is equivalent to there exists x negation P of x is the negation. So now I have to write the negation of the statement. So we have to write first negation of the quantification we have written here, then the negation of the statement we have to write. So what are the possibilities? There will be many possibilities. We can express this statement. So we can express this statement as in many ways. So first of all, we can say that first in many ways we can express. I'll give you some of the expressions here. So first of all, you can express this in first case. It is not the case that, like this also you can take. In many ways you can take. It is not the case. You can include this way. It is not the case that every student in your class has, every student in your class has taken a course in calculus. Now second one, you can express this in another way. That is also, you can express that there is no student, there is no student in your class who has not taken a course in calculus. Like this also you can write this statement. In many ways you can express. So in simple ways many and also you can express the statement as like this also. Every student in the class has not taken. So negation is for all x, that is the for all x is given here. So negation means there exists. So you can say that some students in the class has not taken the course in calculus. Like this also you can write this. So it is not the case that you can mention here every student in the class in your class has taken a course in calculus. Second way, there is no student in your class who has not taken a course in calculus. So this is the negation. Hence the negation is there exists x, negation p of x is the quantification, and the statement is in this way. So you can express this. Now next one. The next we have to remember this one. So the De Morgan's law for quantifiers. The De Morgan's law for quantifiers. This is a table given here. You have to learn this table also. This is the first one and this one is the second law. So negation. Negation is, we know that first of all, for all, remember these two things. I have explained this in the previous class also. For all x p of x, for all x p of x means, it means that p of x is true for all values. It is true for all values of x. So and also some values it is false for some values of x. That means at least one value. So at least one value, if it is false, then the statement is false. Now this is for all. So the negation of this statement is, see the second one, negation for all x means you can write this is equivalent to there exists x negation p of x. This is the content I have taken in the previous problem. So in this is the content I have taken here, negation. See here, negation for all x p of x, which is equivalent to there exists x negation p of x. This is the concept I have applied here. Now in the statement I am taking this is the equivalence condition. So now what is the, when you can say the negation is false. Now when you can say this negation of this statement means negation of this statement. So negation of this statement means this should be false and this statement at least one should be true. You can understand the statement. I think you must remember, if you remember this statement, it is easier to understand these two statements, false or true. So when it is false or when it should be true, you can, negation is, see here, negation is there is an x in p of x should be false. So this is false should be here and that should be true here. So this is true. This statement should be true and it should be true for all values statement is there. No, that should be false. So p of x is true for every x when it becomes false. Now there exists a statement. So we know that there exists a statement. Listen here, let me have a content here. First of all, I told you when we take the values here, you must have to remember all these concepts here. So the previous concept I have explained here, that those things are also very important, which if you remember means it is easy to understand the problem also. Otherwise it takes a little bit time to understand this one. So now listen here, if I take like this, and for all there exist means we say that it is true for some values. It is true for some values. This is the condition for this, some values, and it is false for all values of x. False for all values. So like this we are taking. So negation of there exist means this true should become false and this should become false, statement becomes true. So here see here, when it is true, it is for every x, for all values of x, the statement should be false എന്നുള്ളത് true ആയിരിക്കണം. അടുത്തത്, there is an x for which p of x is true. So this statement is true is given here, no? That should be the false, because negation എന്ന് പറയുമ്പോൾ ഈ സ്റ്റേറ്റ്മെൻറ്റിൻ്റെ ഓപ്പോസിറ്റ് ആയിരിക്കണം സംഭവിക്കേണ്ടത്. So don't confuse with the statements. So when you take this one, you have to remember the original statement. So then you can identify then you will be able to write this negations also. Don't remember the negation and both statements. If you remember this one, it is very easy to understand. Now let us move on to another example. What are the negation of the statement? So first of all, let me take here two statements. One is, there is an honest politician, and another one is, all Americans can eat cheeseburgers. So these are the two statements. These two statements, how can I express this? All Americans can eat cheeseburgers. How will you write this statement? Here, first of all, let me define here the first statement. So let us take first to define the random or the domain. Take a variable x and we define a domain as to be, there is an honest politician, which means that let us take the domain x to be politician. So the statement, there is an honest politician, can be expressed as the predicate p of x to be, x is honest. So we can say that the quantification of this statement is, we can write this quantification as, there exists, because there is an honest man. All men are honest, it is not mentioned here. There is an honest politician. So some are honest. That means there exists x p of x. So this is the quantification. Now the negation of the quantification. What is the negation of this one? So the negation of this quantification can be expressed as, negation, there exists x p of x. We know that this is equivalent to, for all x, negation p of x. So the negation of this statement, so here this is equivalent to, I have written here, there exists x, x p of x is the statement, then the negation is, negation, there exists x p of x, which is equivalent to, for all x, negation p of x. Now the statement, how can we express the statement? So you can say, how will you express the statement? So there is an honest politician. How can we express this statement? So we can express this statement in many ways. So what are the statements possible? What are the possible statements we can express? Can you say the answer for this? So if you are able to express this statement, it's a very good example to say this answer. So first of all, let me take a page and I'll explain for that. So first of all, yes, we can express this statement as, let us first, once again I'll repeat this, x is a politician, we have taken as the domain, then the statement, there is an honest politician. Now the statement, let us take it as p of x, the predicate p of x to be, the statement to be, x is honest. So x is a politician means x is honest. So now we have to write the negation of the statement. So therefore, what is the quantification? The quantification, we can express this statement as, for all, so there is means there exists. This is the connective word, so we can take the connective word as there exists. So therefore the statement can be expressed as, there exists x p of x. Therefore the negation we can express as, negation, there exists x p of x, which is equivalent to, for all x, negation P of X is the statement. So the negation of the statement. There are many ways to express the negation of the statement. So the negation can be expressed in many ways. So here let us take first the negation. So I'll give you one or two statements. So let us move on with the first one. So first we can say that there is an honest politician. So negation should be for all. So you can write all politicians are not honest. All politicians are not honest. We can write in this way because for all means all politicians. Negation P of X. Negation P of X means P of X is honest. So negation P means what is that? Negation of P of X is X is not honest. That is the negation. So therefore you can express this statement as all politicians are not honest. Now you can write the next second statement, or in this way also you can express this: every politicians are dishonest. So you can write like this also: every politicians are dishonest or not honest. You can write like this: dishonest or not. Every politicians are not honest. Like this also you can write the statement. Now the third way you can say is not all politicians. Not all politicians are honest. In this many ways you can express this. I have given you 2 or 3 ways. So first of all, there is an honest politician is given you, means you can state that the domain as first of all politician. So P of X is honest. അങ്ങനെ എടുക്കാം. പിന്നെ നമുക്ക് പറയാം there exists X P of X എന്ന് പറയുമ്പോൾ അതിൻ്റെ നെഗേഷൻ എന്ന് പറയുന്നത് for all X negation P of X. ഈ നെഗേഷൻ സ്റ്റേറ്റ്മെൻറ്റ് പലതരത്തിൽ നമുക്ക് എക്സ്പ്രസ് ചെയ്യാവുന്നതാണ്. അതിൽ ഒരെണ്ണമാണ് all politicians are not honest. Next one, every politicians are dishonest. Every politicians are dishonest അല്ലെങ്കിൽ every politicians are not honest. Next one, third way നമുക്ക് എങ്ങനെ എക്സ്പ്രസ് ചെയ്യാന്ന് വെച്ചാൽ, or you can express this in another way as not all politicians are honest. In this way you can express the statement. Now let us move on to the second statement. So the second statement is expressed in many ways, that is all Americans can eat cheeseburgers. It is the second statement. It is given here. You can take the second statement as all Americans can eat. So all Americans, that is here denoted as the domain. So let us take another. This is another statement. The first one is not depending on the second statement. That is another. This is another. So therefore let us take first, let X denote the domain, which consists of all Americans, which means that how will you define the predicate Q of X, which can be expressed as all Americans. That means X can eat cheeseburgers. So X can eat cheeseburgers means you can write the negation. What is negation of Q? I can say X cannot eat cheeseburgers, or it is not the case is that X can eat cheeseburgers. Like this also we can express. So the quantification for this statement is all. All is the connective word here. So all means for all X Q of X. The negation of this statement is negation for all X Q of X, which is equivalent to, you can write by using the De Morgan's law of quantification. By using the De Morgan's law, I can express this statement as there exists X negation Q of X. Now the negation of this statement, so there exist means you can use the connective word as some. There exist means you can use some here. So you can express this statement as, first of all, the negation of the statement is some. You can write like this: some Americans does not eat cheeseburgers. Like this also you can write the statement, or you can write that there is, you can write like this also, some word or there is you can apply there is. So these are the two connectives we are applying here. If you are having there exists symbol, then you can use these two connectives. So this or this first statement or the second statement you can apply. The second one you can write it as there is an American who does not eat cheeseburgers. Like this also you can write the statement. So I think you are clear with this example. So first, there are two statements in this question. One is there is an honest politician, and the second statement is all Americans can eat cheeseburgers. So there is an honest politician means the negation can be expressed as all politicians are not honest, every politician is dishonest. Next, or you can write it as not all politicians are honest. Now we can write the all Americans are can eat cheeseburgers. Take the domain to be all Americans. You can express the statement, the quantification, then write the negation of the quantification. Negation denotes that there exists. So you can use the connective word some. Some Americans does not eat cheeseburgers. Some Americans does not eat cheeseburgers. Or you can say that there is an American who does not eat cheeseburgers. In this way you can express this statement. Now let us move on to the next one. So show that there exists x, the negation for all x. Show that for all negation for all x, p of x implies q of x, and there exists x, p of x conjunction negation q of x are logically equivalent. So how we can express the statement? So first of all, by using De Morgan's law. We know that the De Morgan's law for quantification. So first you have to remember these things. De Morgan's law for universal quantification. You have to remember the statement. So what is the statement? Just now only I have told you in the previous problem. So what is that statement? It is, we can say, if it is negation for all x, p of x, then it is equivalent to there exists x negation p of x. So I am going to apply this in the first statement. So now I am going to take the first statement. Let us write first negation for all x, p of x implies q of x. So the negation for all x, instead of p of x we are having here p of x implies q of x. So this is equivalent to, on applying this statement here I can write it as it is, there exists x negation of p of x implies q of x. Now just you go back 2 section back. So that is the logical equivalence involving the conditional statement. There is a table value or table statements, it is provided there. So just recall the statement. What is that statement? You have to remember that. If possible you remember the statement, because the statement is logical equivalence involving conditional statement. The statement is, you may have remembered the statement, negation of p implies q is equivalent to p conjunction negation q. So I think this is looking in this format. So there exists x, p of x conjunction q of x. I think you can apply here, instead of p you are having p of x, and instead of q you are having q of x. So I am applying this law. I am saying that this is equivalent to there exists x, as it is you write negation of p implies q. That is, we can write it as p of x conjunction negation q of x. So in this format. So from this you can say that the first statement, therefore you can say negation for all x, p of x is equivalent to q of x. That is equivalent to p of x implies q of x is equivalent to there exists x, p of x conjunction negation q of x. ഈ ഒരു ഫോർമാറ്റിൽ നമുക്ക് എഴുതാവുന്നതാണ്. So we can say that these two statements are logically equivalent. Now express the statement as every student in the class has studied calculus using predicate and quantifiers. So express the statement means you have to express the statement in with respect to the conditional statement. So with respect to conditional statement we are going to express this. So every student in the class has studied calculus using predicate and quantifiers. First of all, for every student in the class, the student has studied calculus. Let X denote the student. So first of all, every student in the class has studied calculus. So which means that I can write the statement as X denotes the domain. So I am taking, let X be the domain such that X denotes the student. So let us take the first statement to be P of X. So I can express the statement as P of X such that X has studied calculus. X has studied calculus. I am taking the statement. Now if first of all you remember that what is the negation of this statement? If he is a student, every student in the class means he has studied the class. If he is not a student means there is a compulsion. The negation, think about the negation part and then you move on to the calculation. അപ്പോൾ ആദ്യം ഇതിൻ്റെ ഒരു നെഗേഷൻ അതായത് ഒരു നെഗറ്റീവ് വശം കൂടി ചിന്തിച്ചിട്ട് വേണം നിങ്ങൾ ഇതിലെ കാൽക്കുലേഷനിലോട്ട് പോകാൻ. അപ്പോഴായിരിക്കും കുറച്ചുകൂടി എളുപ്പമാവുക. ഒരു സ്റ്റുഡൻ്റ് അല്ലാത്ത ആൾക്ക് ഈ ക്ലാസ് കാൽക്കുലസ് പഠിച്ചിട്ടുണ്ട് എന്ന് പറയാൻ പറ്റുമോ? നോ, ഇറ്റ് ഈസ് നോട്ട് പോസിബിൾ. സോ you can use conditional ആകുമ്പോൾ the connective word. What is the connective word? It is the connective word is if then. It is better to use this connective word in this statement. You can apply the connective word here. So now here in this statement can be expressed as I can write this statement as I can express this as for every ഞാൻ ഇങ്ങനെ മാറ്റുവാണ് for every student X. For every student X in the class, every student X in the class, X has studied calculus. So I'm rewriting the statement as for every means all student. So for every student, so you can write every student it is given here. That means all students. So that is a connective word here. For every means for all. This is the connective word. So student X is in the class, then X has studied calculus. I can write like this also. Now next one is we can translate the statement as for all X P of X. I can write like this. So for every person X. So I'm translating the statement as for every person X. X is a student in the class who have studied calculus. So I can say that I can apply the conditional statement. Now I am going to apply the conditional statement. How can we apply that? If he is a student in the class, then he has studied calculus. If he is not a student in the class, he may not have studied calculus. So I am going to rewrite the statement as the conditional statement. So for every student it is true. That is means all students in the class. So I am going to rewrite that if X is a student, if X is a if X is in the class, if X is in the class or X is a student in the class, then I'm using the connective word if then. So then X has studied calculus. I can write in this way also. If X is a student in the class, then X has studied calculus. So there comes now this is a single statement. ഇതിനകത്ത് വരുന്നത് ഒറ്റ സിംഗിൾ സ്റ്റേറ്റ്മെൻറ്റിനെ ഞാൻ രണ്ട് സ്റ്റേറ്റ്മെൻ്റ് ആക്കി എടുക്കുവാണ്. അതായത് രണ്ട് പ്രിമിറ്റീവ് സ്റ്റേറ്റ്മെൻറ്റ്സ് ആയിട്ട് ഞാൻ കൺവേർട്ട് ചെയ്യുവാണ്. അപ്പോൾ ഞാൻ ഒരു സ്റ്റേറ്റ്മെൻറ്റ് ഞാൻ എടുത്തിരിക്കുന്നത് എക്സ് ഹാസ് സ്റ്റഡീഡ് കാൽക്കുലസ്. അപ്പോൾ മറ്റൊരു സ്റ്റേറ്റ്മെൻറ്റ് എങ്ങനെ എടുക്കാം? എക്സ് ഹാസ് സ്റ്റഡീഡ് കാൽക്കുലസ് എങ്കിൽ നെക്സ്റ്റ് സ്റ്റേറ്റ്മെൻറ്റ് എന്തായിരിക്കണം? ലെറ്റ് us take first q of x എന്ന് പറഞ്ഞ് നമുക്ക് അടുത്ത ഒരു സ്റ്റേറ്റ്മെൻറ്റ് എടുക്കാം. ലെറ്റ് q of x denote the statement. So I can take this statement. അതായത് ഇത് x has studied calculus എന്നുള്ളത് ഞാൻ p of x എന്ന് എടുത്തിട്ടുണ്ട്. അപ്പോൾ ഞാൻ ഈ സ്റ്റേറ്റ്മെൻറ്റിന് നൊട്ടേഷൻ കൊടുത്തിട്ടില്ല. Let me take another statement as let q of x denote the statement such that x is a student in the class. I'm going to take like this. X is a student in the class. So therefore, if this is, let us take q of x. അപ്പോൾ ഇത് q of x and another statement is this one is then എന്ന് പറയുമ്പോൾ conditional statement. So what is the expression of this statement? This can be expressed as for all x. I can express the statement as for all x. I can write it as yes, here p of x. X is a student in the class. Q of x is a student in the class has studied calculus. That is p of x. I can express the statement as if x is a person in the class, our statement can be expressed as for all x, q of x implies p of x. So that for all x, if x is a student in the class, then he has studied calculus. That is the expression of the statement. So it is if it is asked to express the statement means use conditional statement. So use the conditional statement and express the answer. Now we shall move on to the next question. So the next question is express the statement some student in the class has visited Mexico and every student in the class has visited either Canada or Mexico. The statement is, first of all, let us take the first statement. Write it first. Some student in the class has visited Mexico. So some denotes the quantifier there exists. So I can say that there is a student. I can rewrite the statement such that there is a student in the class. There is a student in the class who has visited Mexico. So first let us take x to be the domain such that x denotes the student in the class. So x denotes the students in the class. So therefore we can again rewrite the statement that x has, again rewrite the statement that x is a student, there is a student x in the class such that, so I can rewrite the statement there is a student x in the class who has visited Mexico. So now this let us take to be and introduce a statement such that we can introduce a predicate as Mexico, isn't it? So let us denote this statement as m of x. So let us take first, let m of x denotes the first statement that, so now listen here, we are going to convert this compound statement into simpler statements. So many simpler statements can be formed from this statement itself. So let us take first, so x denotes the student. So therefore m of x, I'm taking that m has or x has visited Mexico. I'm taking the first statement that x has visited Mexico. Now let me take the another statement. So therefore I can say there is a person x having the properties that x is a student in the class and x has visited Mexico. Now I can write the statement. So here this statement cannot be expressed as there exists x, s of x implies, or let me take another statement s of x. Let us take first what is s of x. We introduce a statement s of x such that x is a student in the class. So therefore can we write like this, so student in the class. So therefore we cannot say that it is not, our statement cannot be expressed as there exists x, s of x is equivalent implies m of x. We cannot say this statement because which is true when there is someone not in the class. So it is true when there is someone which is not in the class. So because in that case, for such a person x, s of x implies m of x. That means student in the class implies m of x becomes either false to true or false to false, both of which are true will be there. Now let us consider the second statement. So this cannot be expressed. This statement cannot be expressed. Now let me take the second statement. So according to the second statement, what is the second statement? Every student in the class has visited Canada or Mexico. Every student. So therefore all x is a student in the class and x has visited Mexico or x has visited Canada. So I can rewrite the sentence: for every student. For every student means for every x in the class, x has visited Mexico or x has visited Canada. So let me introduce another statement. So let us take, first we have taken here two statements. Let us introduce another statement, c of x, such that c of x can be expressed as, how can we express that? X has visited Canada. So for every student in the class, so for every x in the class, x has visited Mexico or x has visited Canada. So now I am going to apply this condition. So here for every means it denotes for all. For all is denoting here. So therefore we can take the statement as in this statement we can express if x is a statement. So here we can apply the conditional statement. So we can use the connective word if then. So therefore you can write the statement: if x is a student in the class, if x is a student in the class, then x has visited Mexico or x has visited Canada. Now I can rewrite this sentence: if x is a student in the class, then x has visited Mexico or x has visited Canada. So for all x, I can write the statement as s of x, that is x is a student in the class, it has visited Mexico, m of x, or is a connective word disjunction, here visited Canada. So I can write like this: m of x disjunction c of x will be the required answer. I think it is clear. Now let us move on to the next question. So the next question is, consider the statements in this: all lions are fierce, some lions do not drink coffee, some fierce creatures do not drink coffee. It is given here. The first is two statements or premises and the third is the conclusion. First two are premises and the third is the conclusion. So x is a lion. So it is given here. X is a lion. It is given here. So let us take first three statements. X is a lion, x is fierce, and not means it is a connective word negation. So remove the connective word and then write the statement. So x drinks coffee. So x is a lion, x is fierce, x drinks coffee. Assume that the domain consists of all creatures. Now we can express the statement as, how can we express that? All. First of all it is given here. All means it denotes for all. Some means there exist. Here also there exist. The first two statements can be expressed as, for all x, how can we write this? All lions are fierce. P of x is a conditional, that is P of x implies Q of x. Now next statement is, there exist x some lions, there exist lions, so P of x implies do not drink coffee, drinks coffee. So our negation of R of x is x do not drink coffee. So this is the negation statement. So therefore I can say that P of x implies negation R of x. Now how can we express the third statement? The third statement, some fierce creatures do not drink coffee. Some do not drink coffee. That is given here. Do not means negation R of x. So this is negation R of x. This is some, so there exist fierce means it is R Q of x. So how can we write? Some fierce creatures do not drink. So this is the conclusion. So here it is mentioned here, ഇവിടെ പറഞ്ഞിരിക്കുന്നത് P of x is implies P of x, if x is a lion, all lions are fierce. Next, some lions do not drink coffee. Some do not drink. That means all lions are fierce and some lions do not drink coffee. So next case is some. So all lions are fierce, isn't it? So therefore both has to happen. So how can we say that? The conclusion for this is there exists x such that some fierce, so Q of x. Next one is negation R of x, isn't it? So what is the relation connecting them? So all lions are fierce and some lions do not drink coffee, which means that lions are fierce, some fierce do not drink coffee is given here. So what is the relation between these two? So they are all lions are fierce and some fierce do not drink coffee. That means how can we convert the statement? Some lions do not drink coffee also. So some lions, so P of x is with respect to Q of x and P of x with respect to the negation of R of x, which means that some lions, all lions are fierce, but some lions do not drink coffee. All lions are fierce, but they are fierce and they do not drink coffee, isn't it? So and means here comes the connective word conjunction. So therefore there exists x, Q of x, conjunction, negation, R of x is the state. Notice that the second statement cannot be written as the second statement is, how can we write this? Is it true? Sorry. Is it true this P of x? Second statement, can we write like this? P of x implies negation R of x. No, it is not possible. So in this statement also this is now wrong. This is not possible. So therefore the second statement, this is the first statement and this is the second statement and this is the third statement. The third statement cannot be expressed as there exists x, P of x implies negation R of x. The reason is that P of x implies negation R of x is true whenever x is not a lion. Whenever x is not a lion. So if P of x implies R of x means if P of x that means if it is a lion then it does not drink coffee. It is the meaning, but it is no, we cannot give here conditional statement because some lions only drink coffee, some do not drink coffee. So this connective word is not possible here. So therefore we can say that this connection can be rewritten as for all x P of x implies Q of x. This is true. Next one, there exists x, P of x, conjunction, negation, R of x. Next one is there exists x, Q of x, conjunction, negation, R of x. So here remember that this statement, the second statement is not possible because the reason is that P of x implies negation R of x is true whenever x is not a line. So that there exists x, P of x implies negation R of x is true as long as there is at least one creature that is not lion, even if every lion drinks coffee. Similarly, the third statement cannot be written as Similarly, the third statement also cannot be written as there exists x, q of x implies negation r of x. Here also it is not possible, because here also we cannot say that some fears do not drink coffee, because some fear, it means that if this denotes what, that means if it is fears, then it drinks coffee. It is not the meaning that if it is not a fears also it drinks the coffee, but it is not mentioned here, because it is given here only some fears drinks the coffee. So therefore we can say that q of x conjunction negation r of x. So in such situations, don't use the conditional statement, use the connective word conjunction or either disjunction. Here we have to use the connective word conjunction. Now next one is, all hummingbirds are richly colored. No large birds live on honey. Birds that do not live on honey are dull in color. Hummingbirds are small. So now P of x is a hummingbird. Let us take first P of x. So P of x means we can take all the creatures as x. So P of x, x is a hummingbird. Q of x, x is large. We can take x is large. No is a connective word. So remove that word, do not. So remove the connective words and make the sentence. So x is a hummingbird. Q of x, let us take x is large. Now R of x, let us take x lives on honey. Now another one more statement, S of x. S of x is richly colored. Why I am taking richly colored. Now here one more thing is there. Assuming the domain consists of all birds, we have to assume that the domain consists of all birds. Express the statement in the argument using quantifiers and P of x, Q of x, R of x and S of x. So we can express the statement in the argument. So one thing we can notice that there are some similar words mentioned here. So here first small, no large, it is given here. So can we say that small is same as no large? We can write like this, small is same as no large. Okay. Now next one, dull in color. It is given here another word, dull in color. So dull in color means it is a word which is same as not richly colored. These two words are same because they are all meaning same. So there is not necessary, it is not necessary to form a new sentence. So first of all, let me take x is a hummingbird, then we take x is richly colored is given here, isn't it? So next one, no large birds. So x is large, x lives on honey, then hummingbirds are small, x is richly colored. Like this you can take the statements. So first of all, when we take the statements, what are the arguments we can say? First condition is very easy, isn't it? All hummingbirds are richly colored. So you can write the first statement as for all x, you can write it as P of x implies all hummingbirds are richly colored. Richly colored is taken as S of x, so implies S of x. Okay, first is easier. Now coming the next statement, no large birds lives on honey. No large bird, x is large. So next, what is negation Q of x? Negation Q of x is x is not large. X is not large. Allengil you can write the statement as x is small. You can write it as x is small. So therefore, how can we express the statement? So second statement is no large birds lives on honey. No large birds, we cannot use the connective word. So some cases we cannot use. So some large birds are there, they live on, so that means small birds lives on honey. It is given here, no large. So how can we express no large? Means negation Q of x, isn't it? We can express this as negation Q of x negation q of x is given here. And next one is lives on honey. Honey means lives on honey means r of x, isn't it? So conjunction, can we say lives on honey? So lives on honey means you can take it as r of x. Now how can we write this? So some no large birds, that means some birds lives on honey. All birds are no alla. So all birds, some birds lives on honey. Some birds lives on honey means it is given here no large is negation q. So negation q of x intersection r of x. So this can be rewritten as some. Some has to be used here. So how can we express the statement? So therefore I can write it as q of x. Now let me take what is q of x, conjunction r of x. What is the meaning? X is large and lives on honey. Can I write like this? So therefore all birds are large. X is large and lives on honey. Therefore I can rewrite the statement as negation there exists x q of x conjunction r of x. Can I write in this format? So q of x conjunction r of x. Now next statement. What is the next statement? Birds that do not live on honey are dull in color. So birds that do not live on honey. Do not live on honey means x lives on honey means it is negation r of x, or dull in color. Richly colored means s of x. What is negation s of x? Negation of s of x is x is dull in color. I can write like this, x is dull in color. So therefore I can say that birds that do not live on honey are dull in color. Do not live on honey. So do not live on honey means this is negation r of x and this is negation s of x. So negation do not live, they are all dull in color, they are not rich in color. So therefore you can say that, can we apply the conditional statement? So if the birds do not live on honey, they are dull in color. So therefore I can rewrite the sentence as for all x, I can write for all x negation r of x. If they are not do not live on honey, then they are dull in color. So I can write it as negation s of x in this format. Now coming to the fourth statement. What is the fourth statement? Hummingbirds are small. Hummingbirds are small. It is given here all hummingbirds are richly colored. So all hummingbirds are small. Can you take this? So small means here we have taken as x is large. So what is negation q? Negation of q is x is small. So therefore what I can say from this? For all x, p of x implies negation q of x. So therefore the first statement is for all x, p of x implies s of x. So they are richly colored. Next one is no large birds live on honey. So x is large and x lives on honey means we can say that q of x intersection r of x. So the negation of that statement I can express this as there exists, the negation there exists x q of x intersection r of x. Next one is third one is birds that do not live on honey or do not live means negation r of x. So if they do not live on honey, they are dull in color, then they are dull in color. So for all x, if they are do not live on honey, then they are dull in color. So you can use the conditional statement. Next one is hummingbirds are small. So we have taken x is large, q of x. Now negation, q of x is small. So therefore for all x, p of x implies negation q of x. So these are the 4 statements of this. So in this value we can express the statements also. That's all the video. Thank you students.